All right, good morning. This is Calculus 1, and we're doing Chapter 3, Section 1. It is chain rule and some other stuff. All right, so it's part 2 of the video. So now starting here, just composite functions. So just basically what a chain rule would be for the sines and all that other good stuff. So all your trigs. Okay, so now right here it says find an equation of the tangent line to the graph there at the point there. Okay? So first, if I'm going to find the equation of the tangent line, I have to get what from my function? The derivative, which is going to give me the slope.
Oh, no, I was looking for outlet. Oh, their data is back there. You just plug it in. Yeah, because it's. Oh, turn it on. There's a little. Thank you.
We did do this one?
Yes.
Hey, you guys, did we do this one?
Yeah.
Yes?
Sorry.
I asked you, oh my goodness.
started it.
Ah, okay. Sorry, forgive me. You know, Fez back there is, you know, the foreign kid is messing us up here.
Yeah.
Okay. All right, we did do this one. I'm sorry. Okay. Okay, so how about this? Did we do this one?
No.
No, we didn't do this one. Okay, are we sure?
Yes.
Fez? Okay, did you do this one? No? Okay. All right, so right here, application, carbon-14 dating. All carbon on Earth contains some carbon-14, which is radioactive. When a living organism dies, carbon-14 begins to decay at a fixed rate. The formula, P of T is equal to 100 times e to the blah. All right, gives the percentage of carbon-14 present at time t years. Notice that when t is equal to 0, the percentage of carbon-14 present is 100%. So, yeah. When the preserved bodies of 15-year-old La Doncella and her 2 children were found in Peru in 2005, 93.5% of the carbon-14 remained in their bodies, indicating that she had died, that the 3 had died about 550 years earlier. It's neat, right? Okay, so now, anyone in here trying to do forensic science? Because, no? So,
It's like investigating like dead bodies.
yeah, so like CSI. So I actually had one student last year that like loved CSI so much, she actually wanted to be like the blood spatter. She wanted to be like Dexter without the killing. Anyway, but yeah, like that type of stuff. Anyway, but yeah, this goes along with it. This is how our calculus can apply to this. Okay, so part A, what is the rate of change percentage, carbon-14, present in the 550-year-old fossil? Okay, so I kind of need some, I think, is there room over here? No. All right, so right here, so I'm going to take my equation here. I'm going to move this to another one. All right, so P of T, so P of T is equal to 100 e to the (121) t. Right? Okay, so now let's go back to the problem. So this is my scratch paper here. Okay, so what is going to be the rate of change for this one? So it's asking what's going to be the rate of change for that 550 years at t equals 550, right? So remember, rate of change is always the what? Starts with S, ends in slope. Slope. Rate of change is the slope, right? That's what we're looking for. We're trying to find that. And to get the slope, I do what? First derivative. Very good. So I'm going to find the first derivative, and it's saying when. And so at the 550, right? So that's what we're doing. So let's go ahead and do that. So it's going to be asking for P prime of T is going to be equal to, now, chain rule. I would take the derivative of this, which is this piece up here, right? Yeah. Doesn't this go out front? No. Say yes. Because the whatever exponent gets times by what's already out there, right? Say yes. Yes. when okay, so like this, 2x squared, where's the 2 go?
No, I said just.
Yeah, okay, you did? Okay, come on, Fez. All right, so the 2 times the 2, right?
Yes.
It's the exponent times the coefficient, the number up front. And that's what I'm trying to get at. So when I do this, it's going to give me a negative 0.121, right? And then E. Now, do I change the exponent on E? No, I don't change the exponent. The exponent stays the same on E. So that's going to be my negative 0.000121t. There it is. There is the derivative there, right? So we found the derivative of that. Does it look like a mess? Kind of a whole bunch of zeros. What's going to help you with this? Plug it in the calculator, right? So we found the derivative, right? The question was, what is the rate of change at 550? So what does 550 really represent? T, right? Yeah, that's my time. That's my T. So in your calculadora right now, y'all doing this.
Don't we need to convert it like?
So it's going to be P prime of 550 is equal to let me see.
It's just undefined answer.
You might have did it wrong. So it's 100 e to the negative 0.000. Was there 3 zeros or 4 zeros? 1, 2, 1 x. Right here, there's the function. Okay, so let me see. That's going to be. Let's change my window, menu, window, settings. Let's start off at 0, and let's go to this to 600, because I'm going to plug in 550, right? There's not going to be, because we're talking about percentages on there, so the rate of change, so let's take a look. That's going to be 0, and this should be 100. Yeah, I changed the window so it looks like that. All right, so there we go. There's my problem, right? Now, I'll show you guys this neat little trick. So, menu, analyze graph. What's this right here? What's this? What's this? There's magic in the air. What's this? What's this? I know you're not on your phone. What is this? Derivative, thank you. Earbuds away. Phone away, please. Thank you. Yes. Okay. All right, thank you. All right, so right here, and what was my position? What's the T I'm looking for? Dang. Hey, look, there it is right there. That's one way of doing this with the calculator, right? So we get this. Now, let's go back. I'm going to do my scratch pad. And we said that it was negative 0.0121, right?
0.01.
Yeah, right?
No, you didn't put 0 before point.
Is the 0 have to be before the point? Say no. No, it doesn't. Negative 0.000121, and I'm replacing my t with what's wrong? Are you okay?
Yeah.
What's going on? You guys are like, I'm getting worried back there, like something's going on, like something's on fire. It's not the hair.
No
Questions, concerns, complaints? No? Okay, did you guys get this far? Yes?
Yes.
Okay, So, Fez, did you get this far? You're still working on it. Yes.
I don't know why it doesn't work. Sorry. I'm broken. It says 75 answer. I just think the same as you putting and it says 75 answer. It's like, oh.
Because you start off with answer. You don't start
No,
with answer.
it
It
says
says
no,
answer.
I didn't do it with answer. I did it without answer. And then it's and then it's answer. Like,
That's the labeling answer.
Oh, do you know why? See that minus sign that you're using?
yes.
What should it be? A negative sign.
Oh, there's a special negative sign?
Oh my god. Oh, come on, Fez.
I didn't know that there's a negative sign. I was just putting minus before I was in. Why it doesn't work?
Anyway.
They put something.
Seriously?
Yes.
You're gonna blame the calculator because you didn't even notice.
But what's the difference between just putting minus and like
There's a huge difference. Here, Fez, have a cookie. There. Now.
Yeah, but it's broken.
So,
Okay.
eat a cookie. There you go.
There, but
Okay, so what is my number? So it's gonna be, what's it, negative what? Zero, 1, 1, right? Okay, in AP Calculus, you always round 3 decimal points. AP Calculus, always 3 decimal points. Now, on this one right here, can someone tell me what this is actually meaning?
That.
It's the change in percent, right? Over time, at that certain point right there. So that means it's going down a really, really small amount. Because if you notice back in our original problem, right here, it said that I had, so after 550 years, there was 93.5% left, right? So small amounts actually change each year, right? That's what it's saying. Make sense? Okay. Oh, wait, go back here. Okay, what is the rate of change of the percentage of the carbon-14 present in a 2,000-year-old fossil? Okay, so now, what do we have to do different for this one?
just like in 2000 instead of 500.
Yeah, because we already know the derivative, right? We know the derivative, and that's going to give me my rate of change. And so now this one, my t is 2,000. Okay, so let me see. Calculator. So I can watch this. Watch. You guys can arrow up,
Enter.
enter, and then just change that.
Just show them
Ah,
You have to move it to the left.
I know.
Fail.
You did.
It's negative 0.
Yeah, make sure you use the negative sign too when you do this.
What's negative?
I know, right? What is this negative thing you're talking about? Is this new concept? Is this kind of like P?
Like negative is minus.
Okay, so now, but they mean two different things.
No.
All right, because a negative means opposite. A minus means something different, like a taken away.
In my language there is.
Yes, and you say pi is P. So come on, we're not going to go with your language. All right, so now for this one right here, what is my value going to be for this?
Negative 0.
0, 0,
9.
9. Even though that there's a 4 here, the 9, okay, that 4, the 9 doesn't make that a 5, and that 5 makes that a 10. It doesn't work like that. So this is going to come out to be negative 0.009. So over my time period that we're talking about, okay, so over the time period that we're talking about, what can you tell me is happening from here to here, from 550 to 2000?
Slow down.
It's slowing down, right? It's slowing down. So the longer it is, the rate of decay is actually slower. So the fastest rate of decay is earlier on. Okay, so, and the rate, since this is going to be percent over time. Okay, so now Leibniz notation. Now, this thing right here is going to help you out a lot. I guarantee you, because every year there's an AP test question that's going to be written just like this. And you're going to have to do problem and not even given a function. You have no function for it, but you have to do this. You have to figure it out given this information. So g prime means the derivative, right? G of x means the original function, right? Okay, and f prime of g of x. So what number should go into here? It's not just x, right? It's not just x. What goes into the f prime is the g of x. So it's going to be like the y value. The y value. So whatever output you get here has to go into the f prime. So we're going to have something like this. So I know it's supposed to be f prime of g of x times g prime of x, right? I just copied that down. Suppose f is, or h is equal to f of g, like this, f of g. What it means is g is in f. That's what that means. G is in f. The notation is exactly the same right here. F of g means g is inside of f. All right, so first, let's take a look. What is g prime of x? Let's go find g, because I'm trying to find it at 1, right? Yes, at 1, right? At 1. So what is g prime of 1? Negative 3. Very good. So I'm going to have a negative 3 here. Okay? So now, we know that 1 is going into g, right? Okay, so let's see. Where's g? So when g of 1, which we have right here, g of 1 is going to give me 2, isn't it? So what goes into f prime? 2. 2 is going to go into f prime. So that's going to be right here, my f prime of 2. All right, looks like everyone just got confused. Are we lost? Go ahead, ask a question. No? Yeah. So this is all of that, and my g prime of x is my negative 3 right here. So that's why I actually rewrote this again, because we have to try to use that other notation to try and go through and find this.
Shouldn't it be 1 instead of negative 4? Because it says f prime of 2.
F prime of 2.
Yeah.
Okay, so now, this says
no,
right...
I mean, shouldn't it be f prime of 1? The one next to it?
No. Look. Okay. This is g prime of the number that's going in there, right? Yes. Say yes.
Yes.
Okay, so now, that means that this is going to be 1. This right here is 1. Okay, so now it should look like this. So g prime of 1, okay, and then it's going to be f prime of g of 1. What is g of 1?
2.
Right? G of 1 is 2, isn't it? So this g of 1 is equal to 2, so it's f prime of 2 times g prime of 1. Because the g prime of 1 right here is going to give me 2. Does that make a little bit more sense there? Because I did plug in the 1. But then because of this, the g prime 1 is 2. That's the way I actually have to get this out. So altogether, this whole thing is going to be a positive 12. Did I clarify that enough? Anyone questions? Because like I said, this is always on the AP exam. Just like this. You're going to have a bunch of weird, funky things like this. Okay? Alright, so I'm going to leave the rest of this for tomorrow. So don't forget, like and subscribe. Do your homework. All homework is due today.